Hey, welcome to day 5 of geometry. Today we're going to look at points, lines, and planes theorems. Now, before we get started, we have a lot of different theorems relating to points, lines, and planes that we need to go through. Now, this first postulate that we have says that through any 2 points there is exactly one line. That just means that if you have 2 points, you can draw exactly one line through them. You're not going to be able to come up with another line, and there's always going to be some line that you can draw. The converse of that is that every line contains at least 2 points. So here you see we've taken the line that you have on the page and drawn 2 points on it. Our third postulate is that any 2 lines will intersect at a point. So anytime that 2 lines cross, the point where they meet is a point. For number 4, we have that 3 non-collinear points define a plane. So this is something similar to what we talked about in class a few days ago. If you have 3 points, they're going to be enough to define any plane. Now, if you have 2 points that are in a plane together, the line that contains them is also going to be on that plane. So that just means that if there are 2 points and they're on the same plane, there will be a line that connects them, and that line will also be on the same plane. Our sixth and final postulate that we have here is that if 2 planes intersect, then their intersection is a line. So any time that 2 planes cross each other, the location where they cross, unless they're the same plane, is going to be a line. The other exception to this would be if you had parallel planes, but don't worry too much about those for now. Now we've got a definition here, perpendicular. Hopefully you've seen this word before in algebra. Perpendicular means that 2 things intersect to form a right angle. Now, you've all seen perpendicular lines before. So you have 2 lines that are crossing at a point to form a right angle. We also have perpendicular planes. The picture might look a little bit weird, but if you look right here, you'll see that there is still a right angle being formed where they meet. And then the last one, we can have a line and a plane that are perpendicular. This can be a little hard to visualize. We've got a line coming straight out of the plane, and again, they're meeting at a right angle. Now, we've got some true and false here using these postulates. So I want you to pause after I read each question and then figure out whether it's going to be true or false on your own and check your work afterward. So, number 1, through any 3 points there exists exactly one line. Pause, see if you can figure that out. The answer to this one is false. In order to make this correct, we would need to say that through any 2 points, there exists exactly one line. Number 2, a line contains at least 2 points. This one is going to be true. A line can actually contain an infinite number of points, but there will always be at least 2. Number 3, if 2 lines intersect, then their intersection is exactly 1 point. The answer to this one is also true. Number 4, through any 3 non-collinear points there exist 2 planes. This one is false. It should be that there exists 1 plane. A plane contains at least 5 collinear points. True or false? The correct answer is false. It must be at least 3 non-collinear points. My apologies for the bad handwriting. Number 6, if 2 points lie in a plane, then the line containing them also lies in the plane. True or false? The correct answer to this is true. And finally, number 7, if 2 planes intersect, then their intersection is a line. Once again, this is true. Okay. At the bottom of this page, you'll notice a picture that has a lot of information drawn on it. I want you to try to go through these on your own. Your teacher will talk more in class about what the answers to all of these are. So, just like before, you'll be answering true or false for each of these statements. Good luck, and we'll see you in class.